Hey everyone! We see giant pipes, massive manufacturing plants, and heavy machinery all the time. But we rarely stop to think about how we keep the tiny, delicate electronic brains inside them running without just breaking the whole system. Today we're diving straight into an explainer that demystifies the maintenance of sealed industrial equipment. We're going to tear down a heavy-duty VAF Instruments flow meter and do a battery swap, step by step. Let's get right into it.
Okay, let's dive into this with a highly specific number, 51,157. That is the massive volume of liquid, measured in liters, that has rushed through the exact piece of hardware we're analyzing today. Think about that volume for a second. That is roughly enough liquid to fill an entire large residential swimming pool. And all of it is being meticulously tracked, drop by drop, by a single self-contained unit out in the field.
Section 1. Meet the flow meter. Tracking the flow.
So here's our subject. You can clearly see the red VAF Instruments branding stamped right on the front, sitting right above that digital display, proudly showing our 51,157 liters. Notice that thick, light blue metal casing and those heavy-duty bolts around it? You can even see a bit of grime and wear on the faceplate. This thing is built for a harsh industrial environment, not some spotless cleanroom. Down at the bottom, you've got these simple membrane-style select and clear buttons. But here's the absolute critical question. How on earth does this device maintain its memory? I mean, if the main power to the factory or the ship goes completely down, how does it remember that exact count of over 51,000 liters without just resetting back to zero?
Well, the answer to that question actually lies hidden inside the unit. And to get in there, we have to perform a really specific maintenance procedure. And it's basically a straightforward three-step process. Step 1, remove the faceplate. Step 2, detach the wiring array. And Step 3, replace the hidden lithium cell. Sounds super simple, right? But as you're about to see on this visual journey, it actually requires a ton of precision and extreme care.
Section 2. Breaking the seal, the physical teardown. The sheer care required to even start this process is pretty fascinating. Notice how the technician's hands, wearing those specialized black Uvex protective gloves, are so carefully gripping the clear plastic faceplate. This isn't something you can just pop open with a flathead screwdriver. It requires physical, deliberate unthreading to actually bypass that external seal. And that tight seal is absolutely crucial. It is quite literally the only thing keeping out the moisture, the chemicals, and whatever industrial grime is on the outside, so it can protect the delicate digital brain on the inside.
Section 3. Exposing the circuitry. Inside the meter.
Now, let's look closely at what's revealed here because the contrast is honestly just amazing. We were just looking at heavy metal pipes, insulation, and this thick industrial casing. And now, look at this incredibly delicate circuitry resting right inside the clear housing. Notice those fine red and green wires connecting the display back to the main, heavy housing? You have to be incredibly careful not to snap those or pull them out of that tiny orange connector block. And right there, taking up a huge chunk of that green circuit board, is our target. It's the original purple industrial lithium cell. It's a chunky, robust battery that's essentially designed to sit quietly and do its job for years.
So the absolute crucial point is this. What you are looking at is the isolated power source keeping thousands of liters tracked. It is the sole lifeline for this device's memory. Even when the massive pumps are shut off and the pipes are totally empty, this tiny purple cylinder is working 24/7 to make sure that 51,157 liter count is never ever forgotten. It's a perfect example of why preventative maintenance matters so much in the industrial world. If that battery dies, all that historical data just dies right along with it.
Section 4. The power swap mission accomplished.
And here is our resolution. The swap is totally complete. Take a look at the circuit board now. The old purple battery is gone, and it's replaced by a fresh, white lithium battery that's securely clipped right into place. You can clearly read the warning labels on it, reminding us that, yep, this is a serious industrial power cell. You can also spot the visual evidence of the work sitting right there in the background. See the red-handled Phillips head screwdriver resting on the metal rim? And those tiny retaining screws sitting nearby on the ledge? It's a job that requires standard tools, sure, but it takes a very steady hand to ensure those delicate red and green wires are safely tucked away before the unit is completely sealed back up to face the elements once again.
And this brilliantly illustrates exactly what we've achieved today. On the left, we have our before state, featuring that older purple battery. And on the right, the after state, with the brand new white lithium cell locked and loaded. Seeing them side by side like this really hits the nail on the head when it comes to the reality of industrial maintenance.
You know, it's not always about giant wrenches, sparks flying, and heavy lifting. Sometimes, it's literally just about swapping out a single battery on a highly sensitive circuit board to keep a massive, multi-million-dollar operation running smoothly and accurately.
Which leads us with a genuinely fascinating final thought to ponder today. What other massive industrial processes rely on a single, hidden battery? The next time you see a giant factory, a massive cargo ship, or miles of pipelines, remember the tiny, hidden components beating away inside them, relying on simple, careful maintenance to keep the whole world turning. Thanks for joining me for this explainer. I really hope it gave you a whole new appreciation for the little things. Keep asking questions and keep learning.